Right, this is FRQ type 4 for AP Precalculus. It's about symbolic manipulations. So we have to write gx is right here, as a single log function with base 10 with no negative exponents. We have to answer in terms of log with base 10 of an expression. This involves using all the properties of logs, as in precisely condensing logs. So gx is 1/2 of log of x with base of 10 minus 3 log of x with base of 10. Okay. Log is a property that whatever is inside the, in the power, inside the log, if it is in the power, it is thrown outside. So I'm going to do it a reverse engineering, that whatever is outside, I'm going to put it to the power, right? That makes sense. So it should be log of x to the 1/2 with base of 10 minus log of base of 10 x cubed. And what is log a minus log b now? Isn't that just log of a over b? Before writing that, I'm gonna decorate this. I mean, actually, you know what? Let's keep it like that. So log of a over b, so log of x raised to 1 over 2 over x cubed. So that's going to look like log with base of 10. And now the base is same, so the power should be subtracted. So it should look like x to the 3 minus 1/2. And 3 minus 1/2 is 5 over 2, right? So 1 over x to the 5 over 2, that should be our final answer. All right. For part 2, they are saying to write h only as a function of cosine. Okay, the moment I read h, I think of double angle identity, because it's sine of 2x, right? So sine 2x over sine x will just become 2 sine x cosine x over sine x. Sine x and sine x is gone, so this is going to just become 2 cosine of x, which is our final answer, because that's what they wanted, only as a function of cosine, and that's what we concluded. Okay. The next is, there are functions j and k given to us, and they're asking us to solve for j equal to root 10. Okay, remember this is no calc. So j is 10 to the x, 10 cube minus square root of 10, and that should be equal to square root of 10, right? Because they are saying that j should be equal to 10. So I just substituted j. Okay. Can I add root 10 both the sides? So it will become 2 root 10. And the base is same, so can I add the powers? So it will be 10 raised to x plus 3 is equal to 2 root 10. And the only way to bring x down here is to take log both the sides. So I'm going to take log both the sides. So log of 10 raised to x plus 3 is equal to log of 2 square root of 10. The power is going to be thrown outside, so it will become x plus 3 log of 10. Can I use log of a times b formula, which is going to be log of a plus log of b? We know that log of 10 is 1, so this is just x plus 3, and this is just log of 2, and 10 to the 1/2 is thrown outside, and this is just log of 10, and log of 10 is just 1, right? So x plus 3 is equal to log of 2 plus 1/2. Subtracting 3 both the sides, so this will be log of 2 plus 1/2 minus 3 is negative 5 over 2, correct? So yeah, this should be our final answer. I'm not writing anything in the base because the default base is 10, so yeah, that's understood. And finally, the last one, part 2, is inverse trig. We have to solve for k equal to 5 pi over 3. So let's do that. K is 2 cos inverse, and this is negative root of 4x, should be equal to 5 pi over 3. I'm going to divide both sides with 2. So cos inverse of negative root of 4x will be equal to 5 pi over 6. I'm going to take cosine both the sides. So cos of cos inverse of this thing is, I'll just write this step. Cos of cos inverse of negative root 4x will be equal to cosine of 5 pi over 6. Cos of cos inverse is just cos, and cos inverse are sort of cancelled, so I'm just left with negative root 4x. And what's cos 5 pi over 6? Isn't that negative root 3 over 2, if you remember the unit circle? Negative is gone from both the sides, so square root of 4x is root 3 over 2. I'm going to square both the sides, so 4x will be equal to 3 over 4. I'm going to divide both sides with 4, so x is 3 over 16. That's our final answer. In the last part, we are given that m is this, and we need to find the input values of m that yield an output value of 2. In other words, 3 sine square x plus cos square x minus sine x should be equal to 2. I don't like this cos because I would like that everything should be in a single trig form. So I'm gonna rewrite cos square x as 1 minus sine square x minus sine x should be equal to 2. 3 minus 1 is 2, so 2 sine square x and minus sine x, subtracting 2 both the sides, so 1 minus 2 is negative 1. This is quadratic, right? You can just replace sine as whatever you like, maybe y for the moment. So this will look like 2y squared minus y minus 1 is 0. This can be factored as, or middle term can be splitted as 2y squared minus 2y plus y minus 1 is 0, which means that 2y taken as a common factor, we are left with y minus 1, and then the other y minus 1 is as it is. So y minus 1 is taken as a common factor, I'm left with 2y plus 1 is equal to 0. This means that y minus 1 is 0 and 2y plus 1 is 0, which means that y is 1 and y is negative 1 over 2. So when y is 1, what is y? Y is sine. So when sine is 1, what is the value of x? And remember, we need to find all the input values, so we have to generalize this thing. Sine is 1 in unit circle only at pi over 2, right? So we will say pi over 2, but we will add 2k pi so that we generalize the solution. So that's a generalized solution. And likewise, when is sine negative 1/2? Sine is negative 1/2 in quadrant 3 and 4, of course. In quadrant 3, the reference angle is pi over 4, so it will be 5 pi over 4 plus 2. Sorry, it's not pi over 4. Pi over 4 is root 2 over 2. Pi over 6 is the reference angle. So 7 pi over 6 is the quadrant 3 angle plus 2k pi. That's the generalized answer. And the other one is 11 pi over 6. So 11 pi over 6 plus 2k pi. These are the answers. What is k, guys? K is just an integer over here. K is just an